All right, we're going to go through experiment 14 report sheet. So at the top, you got to put the temperature that you had on your thermometer in the lab and your concentration of NaOH. The example I'm using had a 0.104 molar for the NaOH, and your HCl. These are both from experiment 12. In this example, I have the HCl concentration of 0.0595. All right, and so we started with water. The initial concentration of OH minus in water, it's 1 times 10 to the minus 7. Initial concentration of calcium, 0. So here is our reaction. It is a calcium hydroxide dissolving into calcium plus 2 and 2 OH minus. 0 is the initial concentration of calcium plus 2. In water, we have a 1 times 10 to the minus 7 concentration of OH minus. All right, and the titration for this example used 1.18 mils of acid when they used 9.92 mils of the filtered calcium hydroxide. All right, so we can use our titration. MV over C is equal to MV over C. And this is HCl, which is H+. This is a filtered solution. It is just OH minus. There is 0 calcium hydroxide. That is a solid. It was filtered out. So this is simply the concentration of OH minus. All right, so our H plus concentration, 0.0595. We use 1.18 mils, and this is H plus and OH minus giving water. So 1 H plus, 1 OH minus. Your coefficients are 1. All right, we're looking for that molarity of OH minus. We use the 9.92 mils of our base. All right, when you push the buttons, you get your concentration of OH minus at equilibrium from your titration to be 0.00708. All right, and so that is what goes right here. That is your concentration of OH minus. All right, so then it asks for the pH, and so you get your POH by taking the negative log of your OH minus concentration, and 14 minus that POH gives you the pH. In this case, the pH is 11.85. All right, so now we got to find the molar solubility. So we have our initial change and equilibrium. All right, so we had the reaction had to go to the right because you had 0 calcium plus 2. You can't have 0, so it's plus S. And this is plus 2S, the coefficient for the OH minus. So at equilibrium, we have S amount of calcium plus 2, and we have 1.00 times 10 to the minus 7 plus 2S for the OH minus. All right, but we know what the OH minus is. It's 0.00708. So that is what this is equal to. All right, so you have your 0.00708 equal to 1 times 10 to the minus 7 plus 2S. All right, so we got to get rid of the 1 times 10 to the minus 7. So we subtract from both sides 1 times 10 to the minus 7. And this is where you find that it didn't matter if you said 0 or not, because when you subtract, you have 1.00708 minus 1.00 times 10 to the minus 7. It doesn't change it at all. It is 0.00708 still. That was such a small amount, OH minus from water, it did not affect that number at all. All right, so that's equal to 2S. So you simply divide by 2, and you have your concentration. You have your S value. So that is 0.00354. So that goes next, 0.00354. The next question is, what is your calcium plus 2? Well, you look back up here, your calcium plus 2 is S. So that is exactly the same number, 0.00354. And then it asks for the KSP. So you simply have your setup for KSP, concentration of calcium plus 2 times the concentration of OH minus raised to the coefficient of 2. All right, so we have our calcium, 0.00354. We have our OH minus from our titration, 0.00708 squared. And so you get a KSP value of 1.77 times 10 to the minus 7. So there is your KSP value. All right, so that was the one with water. When you do a mixture of 20 mils of your NaOH with 20 mils of water, we have diluted it. So in this case, I had a 0.104. That's the first number I wrote, concentration of OH minus, our NaOH. All right, we use 20 mils of that. We use 20 mils of water, and so our final volume is 40 milliliters. So when we calculate it, it is 1/2 of our initial concentration of the NaOH. And so we have a concentration of OH minus of 0.0520 molar. Again, we didn't add any calcium plus 2. And so if we go to our equation, our reaction here, all right, solid, we don't care about a solid, initial change equilibrium. Again, 0 for calcium plus 2, but 0.0520 for OH minus. Again, you can't have a 0, so it has to go to the right to form some calcium plus 2, all right, and plus 2S for your OH minus. So we have at equilibrium, calcium plus 2 is again the molar solubility, but now our OH minus is 0.0520 plus 2S. All right, so we just write down our data. It required in this case 7.40 mils of our acid to neutralize 9.85 mils of the base. All right, so we have our MV over C is equal to MV over C for our acid and our base. 0.0595 was the concentration of our acid. We use 7.40. Coefficient is 1. What is the molarity of OH minus at equilibrium? When we added 9.85 mils of our calcium hydroxide filtered solution, and a coefficient is 1. All right, so you get your OH minus concentration of 0.0447. So there is your concentration of OH minus at equilibrium. All right, next question is calculate the pH. Well, you simply take the negative log of your OH minus, that gives you your pOH, and then 14 minus that gives you your pH, and that should be a 6. All right, so it is a 12.65. 12.65 is your pH. All right, so we have the concentration of OH minus at equilibrium from our titration. That is the 0.0447, and that is equal to the 0.0520 plus 2S. So to get S by itself, we have to subtract 0.0520 from both sides. And this is where our error comes in. All right, this cannot be a negative number. It is a negative number, and it's a negative number because of experimental error. All right, but we keep going, and so we get a negative 0.00730 is equal to 2S. Then we divide by 2, and we get a negative 0.00365. All right. So if you have this experimental error as well, if your solubility is negative, which is an experimental error, you want to take the absolute value of that and make it a positive number. You cannot have a negative molarity. All right, so you put that in as the absolute value, 0.00365. The S is the concentration of your calcium plus 2. Same number again, 0.00365. Then to calculate the KSP, it is the calcium plus 2, OH minus squared. You plug in those numbers, 0.0065 that we just calculated, and your OH minus from your titration, 0.0447 squared. And you have your KSP of 7.29 times 10 to the minus 6. So we're going to do the same thing again, except this time we are with the full concentration of NaOH. The 40 mils of the NaOH is 0.104. All right, so we do our initial, that is 0.104, initial calcium, we didn't add any. This titration required 16.60 mils of our acid to neutralize our 9.85 mils of our filtered calcium hydroxide. So we do MV over C, MV over C. All right, so our H plus, our OH minus, 0.0595, 16.6 mils. What is the molarity of OH minus at equilibrium? Since we use the 9.85, and that gives us a 0.100 molar, which makes the POH easy. That is 1. It makes the pH easy 13. So you have your OH minus concentration at equilibrium, 0.1. You got your pH is 13. All right, so we're going to have the same problem again. All right, so initial, we have 0, we have 0.104. So you can't have 0, so plus S, plus 2S. Again, calcium plus 2 is the molar solubility. And our OH minus is the 0.104 plus 2S. And that is equal to the 0.100 molar. All right, I added a few more decimals here for the subtraction to give more than one sig fig. All right, so we have 0.100, and if you kept the numbers, it was 274. All right, so we have to subtract 0.104 from both sides to get 2S by itself. And here's where the problem is, because that, again, gives us a negative value. But we keep going. Divide that by 2 to get our molar solubility. And again, if your S value is negative, that's experimental error. You will take the absolute value of that number. You will not report a negative molarity. You will take the absolute value, show it as negative, and then you'll show it that I'm using it as positive because of experimental error. And so your S value is 0.00186 molar. That is, of course, the same as your calcium, which is S, 0.00186 molar. Then you have your calcium plus 2, and you have your OH minus from your titration. You plug in those numbers, square your OH minus, and you get your KSP of 1.86 times 10 to the minus 5. All right, so ideally your KSPs would be constant. They were not constant in this data. They were supposed to be constant at a constant temperature. And the more OH minus that you started with, so if we have so the more OH minus that you started with, then it's going to shift the equilibrium to the left, which means less is going to come to the right. So each time as we went down, we added more OH minus. So we should have had less and less solid dissolving. So you should have had a lower solubility for each different run. And I think that was consistent in this one. It went down. Well, nope, not from there to there. Almost was consistent with this one, but not quite. All right, but experimental error is fine, but you should know, you should explain what should have happened in your conclusions. And that is how you fill out experiment 14.